Assalamu alaikum wa rahmatullah. Today our lectures about formation of the RBCs, or it's called erythropoiesis. So first we're going to talk about the characteristic of the RBCs. What is the RBCs? RBCs, it's one of the three major cells produced, blood cell produced from the bone marrow. WBCs, RBCs and platelet. So we are going to talk about the production of the RBCs. The characteristic of the RBCs. Shape of the RBCs, it's biconcave disc, diameter 7.5 and thickness 1 micrometer. What is the composition of the RBCs as cell? So the cell per cell contain 60% water and 40% solid. Okay, so that means 60% of the cells it's water and 40% it's solid, and that 40% it's hemoglobin and ATP. The content of the RBCs, it's not like the other types of the cell. There is no nucleus in the RBCs, therefore no reproduction and no organelles. Their lifespan is about 120 days. This is the shape of the RBCs. When you see it under the microscope, it looks like this. What is the amount or the number of the RBCs in the normal human being? In the male, it's different according to the sex. In males, it's 4.8 to 5.8 million, and in female, it's less, 4.2 to 5.2 million. What is the functions of the RBCs? Why we need RBCs in our body? So the main functions and the important functions of the RBCs is transport of gases. It transports oxygen from the lungs to the tissue, and it transports the carbon dioxide from the tissue to the lungs. Okay, that oxygen, when we're going to discuss the component of the RBCs we have in the biochemistry, you will understand it very well. So we have hemoglobin in the RBCs. As we said, the RBCs contain hemoglobin and ATP. That hemoglobin, it contains iron and globin. So the oxygen bound to the iron in the hemoglobin and carbon dioxide bound to the globin in the hemoglobin. So this is the important and the first functions of the RBCs, transport of the gases. The second functions of the RBCs is buffer. Okay, we're going to discuss it in renal system, in acid-base balance. So one of the functions of the RBCs is buffer, and also its functions of hemoglobin. The third functions of the RBCs, it contain antigen on its surface that determines the types of blood group. So we know any person has a blood group, like me, it's O positive, A positive, B positive, OP, O negative, positive. That group of the blood cells, it's group of the blood, it's the functions of the RBCs. We have antigen on the surface of the RBCs. That antigen determines the type of your blood group. So we're going to start the stages of erythropoiesis. So erythropoiesis, we have two sides of erythropoiesis, in bone marrow and in the blood. So to form mature RBCs, the step start in the bone marrow and end in the blood. So we have steps on bone marrow and steps on blood. So as general, the stages of erythropoiesis. What is the meaning of erythropoiesis? It's formation of RBC cells. We have two phases. We have replication phase and maturation phase. Replication phase, it means increase the number of the cells. This stage on bone marrow. So we have increase just in number of the cell. And maturation phase, when the RBCs become mature, it should be decrease in the size of RBCs precursor, loss of content, nucleus and organelles, and gain of hemoglobin or formation of hemoglobin inside the RBCs. So we're going to start to talk about the stages in bone marrow. We have, as we know, we have pluripotent non-committed stem cells. The pluripotent non-committed stem cells, it's the stem cells in the bone marrow that give us many types or all the types of blood cells. So the pluripotent stem cells, it's nucleated cell. Focus in this point, it's nucleated cell that is divided to form two committed stem cells, either lymphoid or non-lymphoid cell. So from the start, we have a pluripotent non-committed stem cells. It divides to two, just two committed stem cell, either lymphoid or non-lymphoid cell. Okay, so after that we have a committed stem cell, also nucleated cell, that divide to form only one type of the blood cell. Okay, either lymphoid to form lymphocyte, and non-lymphoid that divide to form erythroblast, and it gives us RBCs. Myeloblast forms other types of WBCs, granulocyte and monocyte, and megakaryocyte form platelet. So focus in these pictures. We have pluripotent non-committed stem cell divide to committed stem cells. The committed stem cells either divide to lymphatic or non-lymphatic. Lymphatic stem cell, it gives us the lymphoblast, and non-lymphatic stem cells or myeloid stem cells, it gives us monoblast, myeloblast, megakaryocyte, and erythroblast. The same picture. So the last stage in the bone marrow, after the committed stem cells give us the myeloid cell and give us erythroblast, we have a pro-erythroblast or normoblast. The erythroid committed stem cell divide to form nucleated cell known as pro-erythroblast or normoblast, and it's also nucleated cell. This divide many times and start to form hemoglobin. So all this stage we still in the bone marrow. So after we form erythroblast, this erythroblast give us pro-erythroblast, and the pro-erythroblast, it divide many times, and at that stage it start to gain hemoglobin. The normoblast lost the nucleus and the other organelles to become reticulocyte. So in the bone marrow, this is the last stage in the bone marrow. This normoblast, when if you find question like that, when the RBCs start to lose the nucleus and gain the hemoglobin, in this stage, in normoblast in bone marrow. Okay, and after the normoblast lose the nucleus and start to form hemoglobin, it's called reticulocyte. Here we're going to start the stage in the blood. So that reticulocyte stay in the bone marrow for 1 to 2 days. After that, it's leave the bone marrow and enter the circulation. In the circulation also, it stay 1 to 2 days. Okay, so the first non-nucleated red blood cell, it's the reticulocyte. They stay in the bone marrow for, as we said, for 1 to 2 days. Then they enter the blood and stay for 1 to 2 days before they become mature erythrocyte. What is the percentage of reticulocyte in the blood? It's only 1%. After 1 to 2 days, the reticulocyte immediately it become RBCs, mature RBCs. Okay, it just stay 1 to 2 days. So that means in our circulation, in our blood, when we take sample from our blood, 99% it's mature RBCs, and only 1% it's reticulocyte. Okay, so what happens if we find we have a high reticulocyte count? If the reticulocyte count increases more than 2%, it indicates hyperactivity in the bone marrow as a result of any types of anemia like hemolytic anemia or recent treatment of anemia. Okay, so the last stage of RBCs formation is erythrocyte or mature red blood cell, small cell without nucleus, without organelles, and contain hemoglobin and ATPs. What we need for this formation of RBCs? What we need? So we need normal bone marrow. If there is any disease affecting that bone marrow, it affects our erythropoiesis, like malignancy, like any types of infection in the bone marrow affects the bone marrow. Any disease affects the bone marrow, it can result to abnormal erythropoiesis and other types of blood cell. Also, we need cytokines and colony stimulating factors. We need that factors to replication and maturation of the cell. We need the main hormone of RBCs formation is erythropoietin. Erythropoietin is hormone secreted by the kidney. We need the erythropoietin for formation of RBCs. Without erythropoietin, there is no formation of the RBCs. So what happens if we have a renal disease or if we have low production of erythropoietin? We have anemia. Okay, so how the erythropoietin is stimulated? The erythropoietin secreted from the kidney and the RBCs formed in the bone marrow. What is the stimulus? How the erythropoietin secreted? And as we know, the RBCs, the functions of the RBCs is transport of gases, oxygen and carbon dioxide. So in the renal blood vessels, when we have hypoxia, either due to less RBCs count or the problem in the lung, this stimulates the erythropoietin. Okay, so that means the stimulus of erythropoietin is hypoxia. Hypoxia stimulates the production of erythropoietin. Erythropoietin deficiency results in anemia. We need other hormones for erythropoiesis like androgen, growth hormone, cortisol, and thyroid hormones. And we need also nutrient for erythropoiesis. We need many nutrients like amino acid, iron, vitamin B12, folic acid, vitamin C, vitamin E, copper, and cobalt. We need that nutrients for hemoglobin formation. You're going to understand it in the lectures of biochemistry. So after formation of RBCs, as we mentioned before, the RBCs stay in the blood for 120 days. What happened after that? Where it go, that RBCs? So after 120 days, that RBCs it start to destruct. Where that destruction occur? In the spleen. So what happened? Also, we have stages for RBCs destruction. We have steps on spleen, step on liver, and steps on intestine. So what is the fate of RBCs, old RBCs or abnormal RBCs? So every second, a large number of RBCs are broken down in the spleen. At the same time, the same number is replaced by new RBCs produced in the bone marrow. When the anemia occurs, it occurs if the breakdown is more than production, whereas polycythemia occurs if the breakdown is less than production. So, RBCs destruction. First step in the spleen, the main site of RBCs destruction. Old and abnormal shape RBCs that cannot pass through small capillaries in the spleen are destroyed by the macrophages and the main product of the destruction is the hemoglobin, which give heme and globin. So we have RBC cells without nucleus, without organelles, just cell, 60% water and 40% solid. When that cell destruct, we have water, hemoglobin, okay? And that hemoglobin, it also divide to heme and globin. So the heme released iron, which is needed by the body for synthesis of new RBCs. That ion is recirculate again to reproduce another RBCs. That means when hemoglobin destruct, we have heme and globin. That heme, it gives us iron, and iron recirculate. We have globin. The remaining porphyrin ring is converted to biliverdin and then bilirubin. Okay? So, that porphyrin ring is converted to biliverdin and then to bilirubin. After that, the bilirubin enter the liver and the bile. In the liver, the bilirubin is conjugated to glycuronic acid to water soluble. That bilirubin is water insoluble. Okay, when it's conjugated to glycuronic acid, it's become water soluble. The conjugated bilirubin, which is water soluble, is then secreted in the bile. It gives us the yellow color of the bile. So after that, the bilirubin reaches the intestine. Bilirubin is converted by the bacteria to stricobilinogen and urobilinogen. The stricobilinogen is excreted in the stool, and urobilinogen is secreted through the kidneys. It enters the enterohepatic circulation and appear normally in the urine. Thank you. This is the end of our lecture.